Welcome back. Today we are going to finish dry fitting the sill, confirm some final measurements, and then permanently adhere the sill plate to the foundation. But before we get to that, we had a visitor come on the job site today. This is a rat snake. It's easily it's easily 5 feet. It's trending towards 6 feet. It's a big snake. As I mentioned in one of the other videos, when I was leaf blowing around the sawmill, we have a lot of snakes in the area, copperheads in particular. So these rat snakes are good to have around because they go after rodents and they control the copperhead population, which is nice. But now let's get back to the sill plate. So we have about 180 linear feet of sill plate. I chose 2x8 pressure treated 12-foot boards, which was about 15 boards to go all the way around, probably 16 with cuts. I am dry fitting this as a reminder because the foundation is not perfectly square. There's one wall in particular that has a kick to it that I'm going to have to make adjustments for on the sill plate so that the sill is perfectly square. We don't want a situation where the sills are out of parallel with one another because that just makes for problems in the framing process and, quite frankly, with the rest of the construction project. If you start square, you end square, and that's what you want to shoot for. So I've dry fitted the entire sill plate around the entire foundation. Took some preliminary measurements before I did it to site where I believe I want the sill plates to land on the foundation. And then once I get fully around and everything is dry fitted and secured, I'm going to re-measure, and we'll see a little bit of that, all of the parallels and around the entire foundation to make sure that they're exactly where I want them, at which time I will go back and permanently adhere the sill plate to the foundation. Up to now, I've been mostly focused on how square and parallel the sill plate is, but the other important piece is how level it is. I have a transom here, outdoor laser level. This is a Johnson. It's about $500. I also used it to help when we were doing the initial grading, so it's a good tool to have around, especially if you have a large piece of property. Especially if you have a large piece of property that has a lot of hills on it, because it just makes things easier. But what I'm doing is I've set up the transom on that scaffolding, as you saw, about a foot above the sill plate, and then I take my laser receiver and I go around about every 4 to 6 feet, and I'm checking the level. I started in that corner that I'm at right now and went around the entire level, and then I would mark, how far off of level it is. So in that case, you can see it's 5/8 inch low, so I would need to bring the sill plate 5/8 inch up in order to make it level with my initial mark. And here, a 1/4 inch up. So we just have to check that all the way around. You can also see here I've marked the beam center, so that's where the beam is going to land. Here it's perfectly level with the original location. And this is marking where the center of the post will be in the room that's perpendicular to the beam. As it turns out, the location that I started with was the highest location on the entire foundation. And so the vast majority of measurements around were 5/8 low, which means that I will start 5/8 because that's the lowest point, and and any other place that I need to adjust, I can adjust from the top. And what I mean by that is I'll adjust it on the rim joist itself. So for my purposes, the sill itself is level enough, the foundation is level enough that I don't have to make any adjustments to the sill itself. I will have to shave off just a little bit on that high side, that high point that I found from the rim joist, but that'll be easier done on wood than concrete. And it keeps me from having to raise the sill off of the foundation excessively because you really want a tight seal there as much as possible. So now that I've finished dry fitting and leveling and double checking my measurements, now I'm permanently adhering the sill to the foundation. So I'm putting on just a foam sill seal. I like to cross the corners at the corners. I also have a small leaf blower here that I can blow off any wood chips from drilling out the sill plate or any other concrete. I'll also you'll see me with a hammer and a chisel, sometimes knocking off little burrs of concrete that are on the top. A couple other notes on sill plates in general. I think in most places the code is to have a minimum of a 2x6 sill plate. As I mentioned, I went with a 2x8. I'm overbuilding everything just a little bit. Um, and I did the same thing with the foundation wall. Instead of an 8-inch wall, I went with a 12-inch wall. Those decisions help because since there is this wall here, as a matter of fact, that's as out of square as it just gives me the leeway to correct things at the sill plate level rather than having to just deal with it through the rest of the construction process. A couple of other things are obviously you can't have a continuous sill plate on a 30-foot wall, so you're going to have cuts. You want the sill plate to be continuous at least 4 feet beyond the corner of the well, beyond any corner, and you always want at least 2 permanent concrete anchors in every sill board. So that's something you might need to work around and just measure around. Here's I'm just knocking down some concrete burrs. A good framing hammer with a waffle head is perfect for that. That hatchet hammer is also great because you can just kind of skim across and knock stuff off. But again, nice clean surface when you're putting this foam down, and permanently adhering is a good strategy to have just so that you can make it as airtight as possible. This sill seal also helps against little bugs and things like that as well. And then the other thing is that you have to have an anchor bolt. In addition to having 2 in every board, you also have to have one within 1 foot of the end of a board so that it doesn't have a tendency to pull up. Um, so I've got my generator fired up because I don't have any electricity out here yet, and I'm going to start to drill a couple of different areas to put in some concrete anchors, strike anchors that I'll show you in a minute. In order to secure these last pieces of board, you still want at least 2 anchors that were buried in the initial concrete pour in every board, but it's perfectly fine to have these strike anchors as additional supports in areas where maybe an anchor didn't fall or one got broken or something to that effect. These strike anchors are great. There are different kinds of these. Some don't have this nail in them. Really, what you want to do is just kind of, tap it in and get the washer and the nut on and get it flush. And then once it's tight and secured, then you can really slap that nail down into the body of the anchor, and it spreads the feet of the anchor into the concrete so that it can't come back up. I've tried others in the past, and this is the kind that just really seems to work the best. I've never had any slippage. I never have any issue with the bolt trying to pull back out. And the way you test that is by, just getting a wrench and really cranking down on it. These are the ones I happen to be using. Like I said, they're strike anchors. There are like I said, a different variety of them, but these are the ones that I really like. The nail in the top can come out, and usually what I do is I flush the bolt to the threads and then tap that in. I didn't do that on the other one. I just tapped it in because the hole was a little loose. I'd rather over drill it than under drill it, of course, because you want to get enough bite on the thread. These are 4 3/4 inch anchors, and that gives me a solid 3-inch depth when it's set to the height of the sill. That's it for now. Thanks, and see you next time.